So since a is 0, I can rewrite this by going 2x squared divided by x plus 3x divided by x plus 1 divided by x. That's right. 2x plus 3, because in each one of these right here, this x will cancel with one of them. This x cancels with x, right? And in the last part, we have a remainder of 1, right? Our remainder is actually 1. But when we write it as a polynomial, we'd write it as 1 over x. So now, it says rewrite 2x squared plus 3x plus 1 as q of x. Now, what does q of x stand for, you guys? The quotient. And it's really talking about this part. It's the answer without the remainder. Okay? So we're going to rewrite it. We're going to write 2x plus 3. And then it says times x minus a. Well, what is x minus a? X times x plus p of a. What does p of a stand for? A remainder, which is just 1 when we write it this way. Okay? Now, you guys, does that side right there equal the 2x squared plus 3x plus 1? Yeah, if we multiplied it out, these two things are equal to each other, right? Okay, because I'd distribute the x and then add the 1. I would get 2x squared plus 3x plus 1. And so we've written it, so we have q of x, we have x minus a here, and we have p of a right here. That's how we've written it. We rewrote this thing as that. That's what it's asking you to do. Okay? Any other questions? Number, Rebecca? 8? Hey, you guys, by the way, number 7, rewrite x, oh, no, never mind. Is it that one? Yeah, I should have given you that, huh? I have it right here. Hey, you guys, number 7, it's referring to problem number 6. You got to use the stuff in number 6 to do number 7, so you know. Someone said 8, so I'm going to do 8. It says, what is x squared plus 2x minus 1 times x plus 3? So, first of all, x squared plus 2x minus 1 times x plus 3. This is number 8. We finished 5 a long time ago. Okay. Okay. X squared times x is x cubed. X squared times 3 is 3x squared. 2x times x is 2x squared. 2x times 3 is 6x. And then negative x minus 3, right? So I get x cubed plus 5x squared plus 5x minus 3. Okay, so it asks us, number 8 asks us to multiply those two together. We did, right? Now it says rewrite x cubed plus 5x squared plus 5x in the form of q of x times x plus 3 plus p of a. Okay, so it wants us to write it using the quotient. So if you divide x plus 3, you guys, into this right here, if we were to divide that into that, that's what it's asking you to do. I know the wording on this, is really bad. So, well, it already gives you the answer. Well, actually, sorry, I said that wrong. Okay, it is assuming, well, that part that says rewrite x cubed plus 5x squared plus 5x in the form of q of x times the x plus 3 plus p of a. What are Q of X and P of A? Okay, well, so it's saying, you guys, if you take x cubed plus 5x squared plus 5x, that is equal to taking the x squared plus 2x minus 1 timesing it by x plus 3 and adding the remainder, which is 3. That's what it's asking you to do. I think that's what it's asking you to do. Yes, that's what it's asking you to do. Well, when you multiplied these two together up here, you got this right here, right? How is this different than this? Okay, you had a minus 3, right? Yeah. Well, what? Because what you were doing is if you times these two together and add 3, you will get this. Okay, and this, I don't know why they had you multiply those two together first. I'm not understanding their thinking right there. I think they're just trying to get you guys to understand quotients, divisors, factors, and all this. The people who wrote the lesson for this, I'm just following a lesson that I found online. Okay? No, because see this right here? Okay? Notice this one's not the same as that up there. It's the only difference is a minus 3, right? So, yeah, exactly. This is the quotient. This is the divisor. This is the remainder. If you were to divide x cubed plus 5x squared plus 5x by the x plus 3, that's what you would get. Okay? Okay. Yes. Why is it what? Why is it the quotient? Because it said it was the quotient. It said it was the quotient. Well, okay, go back to the top right here. Audrey, go back to the top. Hey, you guys, it makes me really frustrated when I'm trying to teach and other people are talking. Okay? Okay, this x squared plus 2x minus 1 times x plus 3, it asks you to multiply it together. Well, when you do that, you get this answer right here, right? Okay? Now, down below, let's see, let me read this again. Rewrite x squared plus 5x squared plus 5x in the form of q of x times x plus 3 plus p of a. So it wants to assume now, what if you take x cubed plus 5x squared plus 5x and divide it by x plus 3, rather than this right here? What if you did that? Well, what would it look like if you wrote it as a quotient, a divisor, and a remainder? And that's what it's asking us to do, is to rewrite it that way. So the quotient right here, if you divide this thing right here by x plus 3, you would get x squared plus 2x minus 1. That's what you would get, plus the remainder of 3. I wouldn't worry about this. Don't worry about this part too much, okay? Who's that for? Here. Okay, Jacob. You guys pass that back to Jacob. Right back there. Okay, now, let's go to the next one. What's your next one, you guys? Okay. 6. Let's do 6. I am not going to do all of them. You might have to finish a couple of them yourself. Have you done this part of 6 yet? Where it asks you to multiply those together, what do you get? X squared plus what? That's what you should get. X squared plus x minus 12, right? Okay, so we multiply those. It says, what is the remainder when x squared plus x minus 13 is divided? Okay, notice, okay, what is the remainder when x squared plus x minus 13 is divided by x plus 4? So what if we did this? It's saying this. What if we went x squared plus x minus 13 and we divided by x plus 4? Now, notice that x plus 4 times x plus minus 3 is this, right? They're just telling you to do something different. They want you, yeah. Well, it's not completely separate. It's kind of related because, yeah, because you know that x plus 4 times x minus 3 is this right here, right? So what if you divided this, which is very close to this, but not quite, by x plus 4? You're going to get x plus 3 with a remainder of 1, right? That's what you're going to get. Huh? Oh, it's x minus 3. Sorry, I wasn't looking up there. We know, you guys, we know that x plus 4 times x minus 3 is this, right? So if I take this, which is just slightly different, the only difference is that's a negative 13, that's negative 12, right? If I divide this by x plus 4, I will get the x minus 3 with a remainder of 1. Or is it negative 1? Negative 1, yeah. No, it'd be a negative 1. Wait. Because if you divided it, see, let's go. Let's just do quick division right here. We'll go negative 4, 1, and 13. And is it negative 13? Negative 13. Negative 4 times 1 is negative 4. Add negative 3. Negative 4 times negative 3 is 12. Add, you get negative 1. So it's negative 1, yeah. Huh? Yeah. Remainder of 2. What are you talking about? Yeah. You can do synthetic division, or you can do the remainder theorem. I could have done this, you guys. I could have put negative 4 in right here, and that's going to be 16 plus negative 4 minus 12. Oh, wait. I'm talking about 13, if we did 13, right? And if I did that, 16 plus a negative 4 is 12, minus 13 is a negative 1. So whichever way you do it, it tells you the remainder. Whether you do synthetic division, the remainder theorem, or the long division, you're going to get a remainder of negative 1 if you divide this by this, right? Okay, so my answer is x minus 3, and you can see x minus 3 right there, remainder negative 1. Okay, so it wants us to write this in the form of the q of x. Oh, what is it? Number 6. What is the remainder when x squared plus x minus 13 is divided by x plus 4? Oh, the remainder is negative 1. Okay, so in number 7 it says rewrite x squared plus x minus 13 in the form of, so x squared plus x minus 13 in the form of the quotient. What's the quotient? Just x minus 3. X minus 3 is the quotient, right? Because that's, the quotient is what you get when you do the division. It's the answer to your division problem, right? So it's the quotient times what you divided by. What did we divide by? X plus 4. That's called the divisor. Minus the remainder, or adding the remainder. So plus a negative 1, or you just put minus 1. Okay? Now, if you multiplied x minus 3 times x plus 4, and then you minus 1, you would get this right here, right? So do you see how they're related? Do you see why they wanted you to do that? And that's the same with number 8 down below that we were doing. You guys are having trouble. There's probably nothing in it. Don't worry about it. So, no. What I need to do is get you guys going on those things again sometime. You need some blue boxes. Yeah, I need to remember that. Okay. Yeah. Right. I need to get some. I'll get some. I'll put it on my list. Okay. Thanks. You too. Okay. Any other questions? Go through this one more time? Yes. Okay. Okay, what we had is in problem number 6, they asked us to multiply those two factors together, right? And we got this, and we had a negative 12 right there. Now they said, but what if you took something that's slightly different, x squared plus x minus 13, because that's slightly different than this, right? And you divide it by x plus 4, which was one of the factors you got to get this right here. Then it's saying if you divided it, you would get a remainder of negative 1. And we did, and I showed you using the remainder theorem and synthetic division that you get a remainder negative 1, right? Okay, so now on problem number 7, it wants you to rewrite x squared plus x minus 13 as a quotient times the divisor remainder, okay? And so our quotient, when we divide this by this, we get x minus 3. So that was our quotient. Then our divisor was the thing we divided by, times the divisor, minus 1. Okay? You guys remember I showed you some problems, some basic problems the other day? Let's take 25, for instance, and let's say I wanted to divide it by 8. 8 doesn't go into 25 easily, does it? Okay? So if I divided it by 8, what's the quotient of 25 divided by 8? 3 with a remainder of 1, right? Because could I rewrite this as this, you guys? 25 equals the quotient times the divisor, 8, plus the remainder of 1. Could I write it that way? 3 times 8 is 24, plus 1 is 25, right? So it's the same thing, except for we're using polynomials to do it rather than real numbers. That's what I'm trying to get you guys to see. Quote, yeah, well, honestly, on some of these problems, you could use, like on number 6, they could have done it the other way around. They could have used x minus 3 as the divisor, and x plus 4 would have been the quotient. Audrey. You just asked me a question, so. All right, okay. Yes, you can switch it. Okay? Because a quotient, I can take any number and divide it. Like, take, for instance, 12. The factors of 12 are 3 and 4, right? So I can divide it by 3 and get 4. I can divide it by 4 and get 3. They're interchangeable as far as which one you use for which one. Okay. All right, are we ready to turn this assignment in? Okay, I'll do 10 and that's it. No, you're on your own on 9. You guys, number 9 is exactly like 6 and 7 combined. Okay, number 10. We'll watch number 10 one more time. Let's see if we can get this. If we rewrite x squared minus 4 as q of x times x minus a plus p of a, which values of a will make p of a equal to 0? Okay, you guys, this one's a lot easier than it looks. Okay, does x squared minus 4 factor? What are the factors? Okay, so this is a difference of 2 squares, and so factors would be x plus 2, x minus 2. Now, it says, if we rewrite x squared minus 4 as q of x times x minus a plus p of a, which values of a will make it p of a equals 0? Well, the values of a would be either 2 or negative 2. Because look, if I took x squared minus 4, and I divided it by either one of the other two, like if I divided by x plus 2, what's my quotient going to be? If I went x plus 2, I would get x minus 2. It wouldn't even have a remainder, would it? I could put remainder 0, okay, out here. Or if I took x squared minus 4 and divided by x minus 2, what would I get? I would get x plus 2, right? With a remainder of 0. So, yeah, well, yeah. And when it wants to know what the a value is, and so you just take, what number could I put in for x minus 2 right here? 2. And down here, what would I put in for x? Add 2 and get 2. Negative 2. So 2 and negative 2 are the answers. Because it wants to know the value of a. Look, you guys, x squared minus 4 can be written as a quotient. Let's say, it doesn't matter which one. My quotient, let's say my quotient is this one right here, x minus 2, times the divisor, x plus 2, right? Plus the remainder, 0. Are those true statements? Is this a true equation? Does x minus 2 times x plus 2 plus 0 equal x squared minus 4? Yeah. So here is my quotient, here is my divisor, and here is my remainder. I can do it the other way around. I could have written x squared minus 4 equals x plus 2 times x minus 2 plus 0. And I could have used this as my quotient. This is my divisor. And that is my remainder. Okay. Yeah, it should be the same. I believe it would be the same, yeah. Yeah, it'd have to be the same. Yeah, it would have to be the same because it doesn't matter. Which way you multiply them is interchangeable. So, yeah. Okay. All right. Okay, now. Hey, did you get one, Colby? Oh, who was it asked me for? Was it you or Ryan? Ryan, did you get one? Huh? She never got the. Did she bring him back? But no, that was because I found one. Oh, yeah, here they are. Ryan. I do that because I'm going to have to put it on the test and everything, but they want us to. And so you know which, you can connect it to the words right here. But the words are what's important. You're going to identify zeros of polynomials. Now, you've already done some of this before. You've identified zeros of polynomials before. But today we're going to only work with real zeros. We don't care about the imaginary zeros. And you guys have several methods of finding them. Okay, it says when suitable factorizations are available. And I'm going to go beyond that. You can factor you will be able to factor the quadratics, but you can, for beyond that, you're going to be able to use your calculator and locate these zeros. And use the zeros to construct a rough graph of the function. We're going to be working backwards with this. This might be a little bit new to you, but you'll catch on fast. The other class did, so I figure you guys will. Okay? And defined by the polynomial. So this is what we're going to do. I want to know if I told you that I have a polynomial of degree 3, and I told you that 3 of the solutions were negative 4, positive 2, and positive, let's make it positive 5 maybe. If I was to give you those 3 solutions, would you be able to write a polynomial equation that has those 3 zeros?
Not yet, but I'm sure I will be.
You guys have all the tools to do this, okay? Go ahead in your groups and do it. If you need a hint, I'll come help you. In fact, I'll give you one hint right off. Write them as factors first. You got the solutions, write them the factors. Okay, I'm going to come around and see how you're doing on it. Okay, so all you had to do is take the 3 solutions, write them as 3 factors, multiply them together, and you would get a polynomial. Now, to To make it a polynomial, I'd probably want to put y equals or f of x equals, right? Equation. Now what I'd like you to do, without using your calculator, I want you to draw a rough sketch of what this graph would look like. Now think about this. You have learned about end behavior. You know basically what kind of function is this, you guys? It's a cubic, right? You know basically what a cubic function looks like. You know what end behavior looks like. You know 3 solutions on this thing. Okay? Draw a rough sketch of it on your paper. This will also be on the test. Okay, so if I graph this now, I know certain things. I know, first of all, since it's a degree 3, it's a cubic function. I know that I have all 3 zeros. I know none of them are imaginary, right? So there's no imaginary. I know it has to cross the x-axis at -4, +2, and +5. I know that the end behavior of a cubic function is either going to go up to the right and down to the left, or up to the left and down to the right. So that's why we can write it like this, okay? Is because we can see that it crosses. And by the way, and you want it slanting a little bit, right? Slanting this way a little bit. All my kids in my other class did the same thing, so I don't know how we do that. Yeah. Yeah, that's right. Oh, no, that will not work. Because that's a good question. I'm going to ask that one next. Okay, next question. You guys, what would I have to change in order for this thing to go up to the left and down to the right? Talk about it in your groups. Go ahead. Just talk about it in your groups. Okay, who would like to come up and draw a picture of this real quick? Okay, Tyson. There's your x and y axis. Okay, so he's going to draw a 4th degree polynomial that has no real roots. Nothing's worth doing unless you do it really well. What do you guys think? Well, I just said no real roots. Okay, Colby. Okay, come show us. Perfect. Okay, so while he's coming up here, you guys, this is absolutely correct because it doesn't cross the x-axis, right? And a real root is where it crosses the x-axis. Jaleesa. I'm not sure if I follow that. Jaleesa. What? Well, yeah, hey guys, question. Jaleesa said, could it just be a parabola? Well, it's not technically a parabola, but it kind of looks like a parabola. Sometimes 4th degree polynomials will look like a parabola. It will kind of look like a parabola shape. As long as it doesn't cross the x-axis, then it's going to work, okay? All right. All right, so, yes. We're going to talk about that one. Okay, here we go. Next one. Still a 4th degree polynomial that has 1 real root. Okay, draw a picture of it. I'm going to give you 30 seconds in your group. Going to have to work on his lines. What are you saying right there?
I would like to say, go America. I thought it doesn't have to be like 2 little dips. Ooh.
Technically, he's got the right idea. Let me just, but you guys, a polynomial equation will never have any sharp cuts like that. Okay, so he's right in the way that if it touches, but it still has one real root. Okay, it has one real root, but it has multiplicity 2, right? So it's the solution, you guys. The solution. Okay, wait. Let's hear what you said and what you want to say. Go ahead. Is that what you were going to say too? Yeah, and I wanted to point that out. Imaginary roots come in pairs, and so your other pair, I mean, it doesn't physically show up in the graph. There would be two imaginary roots, and there would be one real root with multiplicity 2. So that the factor happens twice, but the root only happens once. Okay? So it only actually touches the x-axis one time. Does that make sense? Okay? If you cross it twice, then there would be two solutions, two real solutions. So it has to just touch it. Go back up.
So if it touches it, it can still go.
Yeah, it has one real root. Yep. Well, if it goes through it, that's a real root too. Yeah, but if this thing went through it right here, it'd have to come back up because we know end behavior on this one's going to be both up to the right and left. Or we could have had this right here, a situation like this, where it touched right there, right? Okay, so we can have it upside down as well. Okay, next one. Same thing, polynomial degree 4 with two real roots. What would that look like? There's several different ways you can do this one. Two real roots. Okay, Drake's going to draw one with degree 4, but has two real roots. Man, that's artist right there. I like it. Good. Okay, is there another way you could draw it? Someone else. Okay, come draw one. Okay, Kyson's going to draw one. Well, technically that's a degree 3 because, or degree, it's an odd degree, right? Okay, any other ideas? Okay, Jaleesa, go ahead. Doesn't matter. No. Okay, so you're saying it touches right there? Yeah, that's only one root. Yeah, we want two roots. It could be yeah, but it's still one root. It's just multiplicity 2. Yeah, that's the one I was looking for. If it touches it twice like that. Each one would be multiplicity 2. It has two real roots, but each root has multiplicity 2. So it'd be like saying, okay, x plus 2 times x plus 2 times x minus 3 times, x minus 3 times x minus 3. So you have two factors the same here and two factors the same here. You're going to multiply all factors together. Okay, what about three real roots? Three real roots. Who wants to come and draw one of that? Three real roots. Need a volunteer. You've already been up here. I need someone else. Okay, you've already been up here too. Okay, right here, Stetson's got it. 3 real roots. Yeah, 4th degree still. 4th degree. That is correct. Because this one has 1 with multiplicity 2, so that's 1 root, and then it crosses twice. You guys getting the idea? Okay. 4 real roots. This is a tough one. Tough one. Who can do this one? Okay, Eli's got it. Here, just hit a new screen. There you go. Those blue shoes are killing me, Eli. There you go. Will that work? Okay, 4 real roots. Okay. Okay, one last type of problem I want you to do. Okay, I want you, let's say I gave you something like this. All right, guys, I want you guys to write an equation that would give. No, I want you guys to the equation of the polynomial that would give that graph. Identify the factors of the polynomial graph. Identify the factors of the polynomial graph. What are the factors of this polynomial that is graphed? Okay? That's a 10 by 10. 10 by 10 by 10 by 10. Ones. Scale is 1. Okay, who's got the answer? Okay. Okay, Tyson, go ahead. Write it. Go write them up there. Yeah, and just write the factors up there. The parentheses. That's a factor. Okay, is he right? You guys? Is that correct? It is. Okay.